Hi, I'm Tom, amateur reader call sign N8FDY, and it's time for another meter review. And today we're doing the Greenlee DM-820A. So you can see the meter and has a little blurb about the functions of the meter, and we will open it up and see what's inside. It's a 10,000 count meter, and it's pretty big. A little ad. We have a case. We have a manual, which is in English and German. And we have some other little tidbits of information of the certificate of conformity, which apparently has to be in every meter that's sold in China. I thought that was interesting. And then they have the little blurb on the back of comparing the different models. This is one up from the bottom of this series, so it's not the high-end one, and it was I think it was $201.37 on Amazon. Let's see what's in the case. And have some leads. And they seem like silicone leads. Pretty nice. Let's see if... Oh, and they're gold-plated. So silicone leads that are gold-plated, we will check those out later. You will not have to buy new leads. Unless, of course, you're a ProMaster fanboy, and then you'll buy one anyway. And comes with a thermocouple. I don't have a way to test the thermocouple to see how accurate it is, so we won't even talk about it. All right. Let's go over the features of this meter. It's third-party tested by UL for Canada and US. It's Cat 4, 1000 volts. It's a 10,000 count meter. It has a basic DC accuracy of 0.08% plus 2. It has a 41 segment bar graph. It has true RMS. It has min, max, average functions, but it's marked as REC on the button. It has a crest or a peak hold. It has a relative or delta function. It has optional PC logging software and USB connection, which costs extra. The software is free, but the interface costs about $80. It comes with a 9-volt battery, and it has the Greenlee limited lifetime warranty. Now we're going to try some DC voltages. To turn on the meter, we want to disable the auto power off. So we're going to hold down the select button when we turn on the meter. Now we'll set it to DC volts. This is 2.5005, and the meter reads it as 2.500, which is right on. This is 5.0009, and it reads it as 5.001. So we'll give it a pass on that because it took that 9 and rounded it up to 10, and so that would be right for this. This is 7.5016, and it reads 7.502. And again, it rounded up, and that's okay, because it's 4 digits. Since this is a 10,000 count meter, you notice we didn't lose a digit like you do on the 6,000 counts. What I really like about the 10,000 count meters is it uses the full resolution in every range, because it can go to 9999. Let me remind you that there's a written review The link is in the description, and it has all the details. Some of the things that I may gloss over here, and there's more measurements and some pictures. That way you don't have to take notes. You can just download the review. So let's look at the rest of the DC voltages I tested earlier. Now all the readings marked in green means that it met the specifications as stated in the manual. And as you can see here, all the readings are green. The millivolt range is 0.12% plus 2. But when you get into the higher millivolts, it's 0.06% plus 2. Then when you get into the voltage range, it's 0.08% plus 2. The impedance on the volts input was 10 mega ohms, and the impedance on the millivolts input was 10 mega ohms. Now we're going to look at some AC voltages. We're going to use the DMM check to generate a 5 volt signal at 100 hertz square wave. The actual voltage generated is 4.9987. And the meter reads it as 5.005. And you see it's a dual display, so it also tells you the frequency. And the frequency is 99.96. Now let's look at the AC voltages I measured earlier. As you can see from the green, all the voltage measurements met the specifications as stated in the manual. Now you notice that the 5 volt square wave signal had a 1% plus 4. So it's well within specifications with the reading we got. The millivolts AC is 0.5 plus 3, and the voltage is 0.5 plus 3. The 3 dB cutoff point for the AC voltage was 20.6 kilohertz, so it could do measurements in the audio range. Now, let's measure some currents. The AC current, 100 hertz square wave, and this signal is a little too small for the frequency counter to lock in on it, is 0.999652. And the meter reads it as 1.01. Now, let's look at some DC currents. This is 0.89 microamps, and the meter reads it at 1.0 microamp. I'll take this opportunity to remind you that meters usually are the least accurate on the low end of their ranges. Sometimes the first 10%, sometimes the first 20%. It has less accuracy than the rest of the range. So for this being the very low end of the microamp range, it's not doing too bad. Here's 9.21 microamps, and the meter reads it as 9.3. Here's 99.0 microamps, and the meter reads it as 99.1. So that's pretty close. Here's 131.8 microamps, and the meter reads it as 132. Oh, sort of little twitchy there. It's going between 131.9 and 132. Here is 1.00 milliamp, and the meter reads it as 1.01. Here's 9.98 milliamps, and the meter reads it as, sort of twitchy. 9.99 to 10. That's pretty much sticking to 10. All right. Here is 99.4 milliamps, and the meter is reading it at 99.4. All right, it's starting to get in line there. Let's look at some other currents that I tested earlier. Well, as you can see by the green, all the current measurements met the specifications as stated in the manual. The amp shunt resistor was 0.01 ohms. The milliamp shunt resistor was 2.01 ohms. And the microamp shunt resistor was 84.03 ohms. That's pretty good. The microamp one is below 100. Many of the meters, it hovers around 100. So the lower the better. Now we're going to do some resistance measurements. First, we're going to zero the leads out. So let's connect the leads together and see what their resistance is. Okay, the meter says it's 0.1 ohm. So now we're going to use the delta, a relative function, to cancel that out. So now it's 0. Now we can take some resistance measurements. Here is 1.004 ohms, and the meter reads it as 1.0 ohms. That's pretty good for its resolution. You may wonder how I know what values these are. I've measured all the resistors, capacitors, and voltages and currents with my Greenlee DM-820A, which is a 6.5 digit bench meter, and it was calibrated at the beginning of the year. So I'm using that to judge these meters and judge these values. The Greenlee is about 10 times more accurate than I think the best portable meter. Here's a 10.007 ohm resistor, and it reads it as 10, which is pretty good. Here is a 100.069 ohm resistor, and it reads it as 100. Here's a 1.0001 kilo ohm resistor, and it reads it as 1.001 kilo ohm. Now, you notice that we're still in delta mode, but we've moved up to the next range. So, most meters won't do that. Most meters, when you put it in delta mode, it puts you in manual ranging. But the higher end Bryman meters, and this Greenlee is actually made by Bryman, and they just put the Greenlee name on it and the Greenlee model number. But all the higher end Brymans will let you use the delta or relative function and keep it in auto ranging. I find that very convenient. Here is a 10.002 kilo ohm resistor, and the meter reads it as 10.01 kilo ohms. Here's a 100.02 kilo ohm resistor, and the meter reads it as 100.1 kilo ohms. Here's a 0.997 mega ohm resistor, and the meter reads it at 0.995. Here's a 9.97 mega ohm resistor, and the meter reads it as 9.98 mega ohms. Well, as you can see by the green, all the resistance measurements met the specifications as stated in the manual. The only concern is it couldn't read the 100 mega ohm resistor, but very few portable multimeters can read that high. It used, on the low range of resistance, it used 1.23 volts. On the medium ranges, it used 0.86 volts. And on the high range, it used 0.46 volts. Now, let's go measure some capacitors. Go into capacitance mode. And you notice that even though the white, which means it defaults the capacitance, it really isn't in capacitance mode. It is in diode mode. Well, this is a Bryman meter, and Bryman meters remember the last selected mode for each location on the rotary dial. So if we switch it to capacitance and we turn off the meter, we turn it back on, and you see it's in capacitance. So I remembered. Let's switch it to diode check. Now it's in diode. Let's turn off the meter, turn it back on, and it's still in diode check. So it does that for every one of these. So that can be convenient once you're used to it. If you're used to the way the most meters work, you'll flip it to the option you want, and then you'll hit select, not even thinking, and you got to be more careful with these because they just remember where they are, so they might be at the place you were last time. Anyway, let's switch her back to capacitance. Let's see how much stray capacitance we have in these leads. This is only resolved down to 10 picofarads. It's the smallest value you can see. So it shows a 2, which is 20 picofarads. So let's zero that out. In my new regimen of testing, we are no longer using the 10 and 100 picofarad ceramic capacitors. This one and that one. Most meters had too hard of a time reading them. So we're going to start with the first film capacitor, which is 1 nanofarad. Here is 1.005 nanofarads, and it reads it as 1.01. Here is 9.921 nanofarads, and it reads it as 9.95. Here's 99.51 nanofarads, and it reads it as 99.8. I'll mention again that we're in relative or delta mode, and because it's a higher end Bryman meter, it still stays in auto ranging. Most other meters, when you put it in delta or relative mode, it actually goes back into manual ranging, and you can't use auto ranging with a delta enabled. So I kind of find that really handy with these Bryman meters, but it's only the higher end ones, the 200 and over meters that I've tested do that from Bryman. Here's 1.009 microfarads, and it reads it as 1.011 microfarads. Here's 10.294 microfarads, and it reads it as 10.92. This is 10.294 microfarads, and it reads it as 10.93. Here's 112.2 microfarads, and it reads it as 113.2. Here is 944.5 microfarads, and the meter reads it as 1.019 millifarads, which is equivalent to 1,018 microfarads. Oh, it's a little jumpy. Now it's 1,017. Well, let's take a look at the accuracy of these readings and see how they fared. Well, as you can see by the green, all the readings met the specifications as stated in the manual. And the capacitance specifications, they're, run-of-the-mill for the lower ones, but for the higher ones, they're pretty good because some of the meters really go up to 5 or some even 10% on the higher ones. So this one's doing pretty good. Now it's time to test some diodes. And we'll start out with our favorite, LEDs. Well, the red LED is not very bright, but you do get the forward voltage, and there is no beeping on this meter. Not for diodes, anyway. Here's the yellow diode with its forward voltage, and it is not that bright either. Here is the green LED with the forward voltage, and it's very dim. Here is the Schottky diode and its forward voltage, and no beep. So this meter does not have the beep if good function for the diodes. Here's the small signal diode and the forward voltage. Here is the rectifier diode with the forward voltage. Let's see how much voltage and current is used to test the diodes. The max diode voltage is 3.18 volts, and the max diode current is 509 microamps. Well, that explains why the LEDs are so dim. That's not much current for testing LEDs. Well, now it's time for continuity check. Let's put the meter in continuity mode. Let's get out the probe masters. Let's try her out. Well, it seems like it latches. Let's see how fast it can go. Pretty fast. Now we're going to try the leads that come with it. And these are pretty flexible. These are the probe masters. Now let's see what these guys do. All right, they're a little less flexible, but they're still way more flexible than the plastic ones. And they have that grippy feel like the silicons have. Actually, it's a little more grippy. So this might be some synthetic silicon thing, but it's still pretty good. But the important part is the probes are gold plated, so that helps with a better contact. So let's see how this does with continuity. That was good. Now let's see how fast we can go. Well, I think these did pretty good. You're not going to need to buy gold-plated leads because they come with the meter. Unless you're a ProbeMaster fanboy, then you'll buy them anyway. But for most people, I think these leads are going to be good. Now let's look at how the accuracy of this meter compares to the other meters in the group. This is a group of meters that I presented to an amateur radio club meeting, and I had to keep it to a more value proposition, so I kept it under $200. And this Greenlee is the most expensive, but it is not the most accurate in the voltage and current ranges. You'll see that in certain cases it is, but in many cases it's not. So if you want to buy a meter in this group strictly for accuracy, I would go with the Bryman BM789 or the EV Blog Bryman 786. Well, looking at the resistance and capacitance accuracy specifications, really it's kind of split between the Brymans. This one is good on some ranges, and the other type of Bryman's good on other ranges. Now, this meter will do logging, but you have to buy an optional optically isolated USB interface. I bought the interface on Amazon for $77.99, and it comes with a CD free software. If you don't have a CD, which many people don't because they're considered pretty much obsolete, you can download the software from the Greenlee website. And it connects kind of a little strange kind of way that it twist locks into the back. And the software only runs on Windows, so I tested it on Windows 10, which you can see here. And I also tested it on Windows 11, and it worked there too. Now the battery compartment is a little tiny one at the bottom, and you unscrew 2 screws, and they're captive screws, which is good, so I didn't lose them. And it has a 9-volt battery. But if you need to get to the fuses, you got to remove the screws that are self-tapping screws in the plastic. So you have to be really careful when you put it back together not to strip the threads. So you got to kind of back them out a little so they catch into the thread that's already there, and then don't over-tighten them. And then here is a close-up of the 2 fuses. Now let's look at the pros and cons of this meter. The good part, it's third-party safety tested by UL for the US and Canada markets. All of the measurements taken met the accuracy specifications as stated in the manual. It's good accuracy specifications for a 10,000 count meter. You can buy an optional USB interface to your PC with free software. And it has a limited lifetime warranty in the USA from Greenlee. Really, the only cons of this is the backlight only stays on for 32 seconds. That is extremely annoying, and there's no way to change it. And there's no Bluetooth interface, which is a shame because it would be handy and it would fit right in the back. But I guess they didn't do that. If you're looking for a 10,000 count meter and you want USA support with a limited lifetime guarantee, this is your meter. And I think it, except for the backlight, I think it works pretty good. If you want a meter with standalone recording functions and a little more options, you could get the Bryman 525S, but you get no support and you have to buy it from, well, I bought it from Germany, but you do have to buy it from outside the US, or you have to buy it on eBay, which is always risky. So, if you need support, your only meter, you'd go with the Greenlee. If it's your second or third meter, and you could get along without it for a while, you wouldn't mind sending it to Taiwan to get it fixed, I would get the Bryman 525S, which is a little cheaper and has a little more functionality. Well, I hope that helps with this meter. Remember, there's a written review. If you're interested in this meter, take a look at the written review to get more details. And this is Tom, N8FDY, saying 73, and take it easy.